Okay, I'm going to have to do this one in sequences for you. As you can see, I've already got the super capacitors. These are very large car capacitors. If you want to, it's upside down. You're going to have to excuse me while I rotate it for you. But these are 2200 watt, 2.2 farad, 12 volt, uh, very, very large capacitors. Pretty expensive too, as far as regular capacitors go. They're about $50 each. Anyway, this was 3D printed for the C-cell batteries that I was making. These are actually an experimental C-cell battery. Uh, anyway, as you can see, that's what they were printed for. Instead, I'm going to use this as a brace underneath because, well, I need something to hold it steady on this thin plexiglass. And after I get all of that stabilized for you, then I'm going to add the machine and the batteries and all of the extra pieces. I was told by a gentleman that he had thought that I was using some kind of device to send static or inductive charge to the machine to keep it running. These are all plastic and 3D printed. If you zoom in, every piece is 3D printed. Inside is, and I sealed it with a 3D print pin. They're really good as like a solder kind of thing to tack it together. And as you can see, inside there is only the circuit. Nothing else inside there, just pretty much a simple circuit. I'm inside the shop right now, working on some things. So what I'm going to do is, at this point, I'm going to have to hit pause for you. After I hit pause, I'll be back with the rest of the video. Thank you. Hi guys, I'm back. I just wanted to show you the machine really quick. Alright, this motor, I got it from Amazon.com. It's a 12 volt at 10,000 RPMs. It's moving at about, I don't know, 1/10 that, so about 1,000 and a half RPMs, something like that. It's charging. There's a diode here that goes down. It's charging at 1.8, something like that volts. Anyway, we'll get back to that. Right here, these are 10 batteries as well. I just wanted to show you, we ran them in series. When you run something in series, you get 1.2, you get 2.4, you get the 3, the 4, so forth until you get all the way here to the end. And all the way at the end, you'll get your 12.5 volts. If you read it from here, you get your 12.5 volts as well. Okay, now the motor starts out using 12 volts at about 400 milliamps of energy. After it's running, it runs at 12 volts at around 200 milliamps of energy. The generator over here on the side that is running, it runs at, the generator pushes out 1.8 volts at around 300 to 400 milliamps of power. Right now it is charging at 1.85 volts, 1.84 volts, something like that. And it's charging these batteries pretty well. These are just, Tenergy, AA batteries. Now those AA batteries, you can charge those pretty quick. I wanted to point out this battery, these are 2.5, around 2 thousand watts. I mean, that's 2.2K. I'm also running over here an LED light. This LED light happens to be 12 volt, 9 watt. Once again, you can buy that at Amazon.com. These super capacitors, you buy it from eBay. This right here, you can buy 3M tape, double-sided sticky. You buy it at, I don't know, I think I got mine at Home Depot. You can get it Ace, Home Depot. I think sometimes you can catch it at the dollar store. Easy enough. I did place rubber knobs underneath of right there. Here we go. Here's a good rubber knob. Let that focus in for you. That rubber knob, I placed those all the way around, you know, underneath, so that, you know, some people have thought that I was using something to induce power. See, I can put my finger underneath everything. You know, if people thought that I was inducing power or something like that, see, that's lifted off the ground. I can stick my nail under it into this machine. Nothing could be further from the truth. It's pretty simple. You have one side over here that drives this motor. The other side over here is the generator that's feeding the power out to these super caps. Now, these super caps, Tenergy batteries you buy at Walmart.com. You can look them up. Those Tenergy batteries are 1.25, I think, 1.25 volts at 1,000 milliamps. This large battery, once again, you can buy it at Amazon.com. And that is a 3.3 amp hour battery, 12 volt. And I use it as a kind of like a reservoir, so that when I'm switching out these batteries after they're fully charged up, when this set here drops to 12.3 volts, I change it out. And I take the ones that have charged up to 1.29 volts and switch it, so I get 12.9 volts. And then I can run it down. And as I run this one down to the 12.3, then the other one is at 1.29. When you switch those, then this becomes 12.9, and this one goes over to the charge until it's done. Now, just to show you how much energy is actually being consumed by this, you know, like I said, 12 volt, 9 watt LED. We're going to disengage it. And as we disengage that, then we're going to watch our voltage here jump. And our voltage will go from low, because, well, we're charging at a very, very low rate. It will go up to about 12 volts. There you go, 10 volts. And that 10 volts, it will continue to climb and continue to climb as it feeds the amps into this. It has to get the amps up to that 10 volts, and for the watts. After we charge up the watts for a while, you'll notice that, you know, it'll climb slowly, kind of like your battery. When you place it onto a battery charger, you're not going to start it off at 13 volts. It's going to go 12.4, etc., etc., until it gets up to its voltage. There's nothing except that wonderful tacky stuff that holds it together, and there's a layer of that all the way around, holding each part of the machine off of the plexiglass. And the plexiglass is then being held once again off of that little thing that I 3D printed for a battery bank, with another layer of that really thick double-sided gummy rubbery stuff. And on top of that, it is also with rubber knobs off of the table, so we don't have anything inductive. We're not sending any extra energy through a table. You know, if you want to, I'll put the meter to the table for you. There we go. Let's poke the meter in view for you to the table. You know, let's keep doing that. See, there's no voltage coming to the table extra to the machine or anything like that. Here, that way you get a good shot. You know, both are, and you can hear me pounding the table. You know, nothing is coming into that meter. And then you can notice that when I connect the meter to the batteries, you'll see your voltage rise. There we go, connected to the battery. And there you go. It's pretty simple. As long as, you know, as long as you're charging, say I take this head and I put it as a 48 volt head, and I get the RPMs up to charge that 48 volt head, and I have enough torque in the motor. By the way, when you scale that up and you get it larger, this is only about, you know, just give you a scale. Here's my hand on both sides. You know, to give you an idea of how, I wanted to show you here, it's free spin. It's not being turned by anything else. It's pretty much free spin. Gaps in there so that you can see that there's not connecting it. See, once again, that wonderful white goopy tape. I separated each thing so that nothing was connected to anything, so that people can't say I'm sending energy from any other place. But once you step this to a 48 volt generator head, 500 watt, and you feed that out, at that point you would feed it out into a battery or a capacitor, and you'd run that into a 48 volt bank or a capacitor bank, whichever you'd like, but you make sure that you have enough farads in there. You'd want to use super caps, like 100 plus farad caps. But the battery discharges slowly, allowing us to use that energy effectively. Oh wow, yeah, we're starting to get some speed there. So if it's speeding up, that's because, well, I don't have enough resistance on this end. So let's give some resistance there. Woo! Yeah, that got bright real fast. There we go. But once you bring that up to a 48 volt head or 24 volt head, and you're charging that into your battery cell, and then your battery cell is feeding. In theory, I'm going to say, in theory, you should be able to continue running that indefinitely. Once again, you have run, a generator, a second generator. Now that second generator is charging 10 batteries that I will take from parallel, put in series, switch the in series to the parallel when it gets down to 12.3 volts, bringing it back up to 12.9 volts. Bringing it up to 1.29, which will bring it to 12.9 back over here. Now, as this becomes a higher voltage, then this gives less resistance to charge, which then means that I have less energy being consumed here. And it goes in a cycle, and it continues to cycle, and it will continue to cycle. All the way into, instead of super caps, what I'm going to do is I'm going to change out the super caps, because these LEDs on the super caps are also consuming energy. Instead, what I would like to do is I'm going to do another video where I change this out and put it into batteries. It'll also make this wiring system setup thing here a lot more clean. After it gets a lot more clean like that, then the battery also has more resistance than these caps, and I can get something that holds a pretty long charge to it. Like I said, this will eventually drop over here. This will drop. I'm not saying it won't. This will drop. As this drops, however, I am refilling these. Now, if you look at the law of thermodynamics, it says that I'm not going to get 12 volts from here over to here. I'm not. I'm getting 1.29 to 1.8 volts over here. It'll charge very slowly, very efficiently, and I'm getting 3 to almost 400 milliamps. I'm consuming 200 milliamps from here. Simple math. And drive. This is my output into these coils that is running this very bright, I don't know if you can see it, but there, it's going to dim itself, but very bright LED. I mean, it's like I said, 12 volt, 9 watt. I hope you enjoy this video. I hope this video sheds some light on what my intentions are and what I would like to accomplish. I told you where I got all the parts from. If you'd like to, it's pretty simple to copy this. It's not too difficult. Thank you guys.